Hello and welcome to another live Q&A event from the NIC. I'm joined tonight by my colleague Richard Owen from the assessment team. How are you doing today, Rich?
Oh, hello, Sam. I'm good, thank you. Hope you are as well.
Yeah. Any interesting visits recently?
Well, funnily enough, today was a non-visit day. Got lots of office stuff done, but yeah, it's good. They're coming thick and fast, I have to say. Hello to any of my contractors out there.
Okay, yeah, so Rich is in the London area, although we know London's a big area. Rich should be able to tell you a bit more about where he is.
Yeah, well, I cover the Croydon area, so CR postcodes and the surrounding areas. Yeah, from east, west, South Croydon, Selsdon, Caterham. It might seem small, but quite a concentration of contractors.
Yeah.
So.
No, it's densely populated, that area, isn't it? And that goes for quite a lot of London, isn't it? In that it's an awful lot of people in a small space. Okay. Well, we'll start off with our question of the week, which we posted out across social media on Monday, and look at our answer to that. Then while the audience are putting their questions in, although I can see there's one question in there already, which is brilliant to see. While people are putting in their questions, we'll go through some of the previous questions from sessions that we haven't got around to answer. All I would ask is that please remember, when you're putting your questions and comments in the chat, remember there's no such thing as a stupid question, only stupid answers. And please remember to be respectful and kind to each other in the chat, as the whole idea of this evening is that we'll help each other out collectively with the aim of improving our knowledge and understanding of all things BS 7671 and the world of electrical installations, because absolutely nobody knows it all, and every day is a school day without a doubt. So without any further ado, let's take a look at the question that we posted out on social media on Monday of this week, and it was a nice one. According to BS 7671, which is the most commonly used protective measure in electrical installations? And the optional answers we gave were A, ADS, B, double insulation, C, electrical separation, or D, SELV. So the question was, according to BS 7671, which is the most commonly used protective measure in electrical installations? And if we took a look, I took a screenshot earlier today of a poll on one of the social media platforms to see how it was going, and at that point in time we had 77% of the people, I think we'd had over about 2,500 votes, but 77% of the people had gone for answer A, ADS. So what's our answer there, Rich?
Well, it's ADS, automatic disconnection of supply, because really we rely on earthing. Most of our wiring has CPCs or earthing in it, and so that all forms part of the ADS. We want under fault the electricity to automatically disconnect.
Yeah. And it was good in that quite a lot of people were commenting, because ADS is a fairly recent term, and there were lots of engineers thinking back about in the days when we would record that protective measure as EBADS, earthed equipotential bonding and automatic disconnection of supply. So yeah, I think there were quite a few people using the question to reminisce a bit about the old times.
It's just been shortened, hasn't it, really? But it's under the same principle.
Yeah. But in that, if we look in 7671, in that regulation that talks about the permitted protective measures against electric shock, if you go to the bottom of that regulation, there is actually a little informative note that we've highlighted there on the screen, which says in electrical installations, the most commonly used protective measure is automatic disconnection of supply. So that was, and I can remember back in the day that used to be a fairly common wiring regs exam question. So I don't know if it still is. It's been a while since I did a regs exam, but yeah, it used to be one of the standard questions in the exam bank. So yeah, ADS officially the most commonly used protective measure, and it actually states that in 7671. So please do put your questions in the chat and we'll get round to answering the questions. While we're waiting for some more questions to appear in the chat, we'll just go through some of the old questions from previous sessions which didn't get answered on the night. So the first one we're going to have a look at is it was quite an unusual one, not something we've been asked before, but the question was, can I use the protective measure of placing out of reach in industrial installations? So placing out of reach is a protective measure which is included within 7671, and the engineer was asking, could that be used in industrial installations? Now our answer there is possibly, but it's unlikely that it will be the only protective measure used if we want to be compliant with BS 7671. So we did make reference to, there is a regulation 417.1 which talks about the application of obstacles and placing out of reach, and it confirms that they are for applications and installations with or without fault protection that are controlled or supervised by skilled persons. So what that's telling is it's making us aware that placing out of reach is only a basic measure of protection and doesn't provide fault protection. So even if we were to use it, we would need a form of fault protection as well. So yeah, the regulation itself confirms that placing out of reach only provides basic protection, and therefore BS 7671 requirements for fault protection would also need to be considered. And then also it confirms that placing out of reach can only be employed in installations which are controlled or supervised by skilled persons. So they would need to be present at all times that the installation was being used in order to ensure that basic protection measure was adequate to provide basic protection, so protection against live parts which should be live. Would you add anything to that, Rich?
No, only that it's really the emphasis on the that measure being suitably controlled, and the skill level of the individual to understand the dangers that may arise from effectively live parts being placed at a height. But you're sort of looking at things like, can machinery hit it, or can anything sort of hit these live parts? So it's total monitoring, isn't it? It's not it's not the most ideal form of basic protection.
Yeah. Okay, question 2. Are domestic kitchen appliances required to have an isolator for compliance with BS 7671, the requirements for electrical installations? So do kitchen appliances have to have an isolator, Rich?
In a nutshell, yes. Appliances, you're talking your washing machines, dishwashers, and things like that. They do need to have means of being able to isolate them. And in actual fact, this is a fundamental principle in BS 7671, Part 1, to provide effective means and ready for operation, that all voltage can be disconnected from these items of equipment to prevent danger.
Yeah.
And remove danger.
Yeah, spot on. And I love the bits that refer always to the front of our standard, the fundamental principles, because that's where a lot of those best practice applied items come from, and yeah, it's clearly there in fundamental principles. It says that every circuit, every installation, and every item of equipment has to have a means of isolation. Very clear. And if you were to look in the definitions of equipment includes, as we've got on the screen there, it includes accessories, appliances and luminaires. They all fall under equipment, so it does fall under that. So yes, a real distinct yes. Now that question actually came with a follow-on, and the follow-on question, which we get asked quite a lot, was, does that means of isolation have to be local? And the answer to that is no. 7671 doesn't specify that the means of isolation for all appliances must be local. What it says is that it must be suitably placed for ready operation so that all voltages may be cut off as may be necessary to prevent danger. So it doesn't go as far as to say it has to be local, because that would also give rise to the question of, well, what's local? How close is local? So it does say it has to be suitably placed. So that means that the designer then has to give consideration about the potential hazard and the possible risk associated with that appliance, because it may be that it needs to be local. You know, for example, if it generated heat because it's an appliance such as a cooker, or if it's got external moving parts like an extraction fan, and the extraction fan is at low level, so it could involve in the users of the installation entanglement, then again you might need something local. So that's how we interpret that requirement that says it has to be suitably placed. You have to consider the possible risks of that item of equipment, that appliance, and then figure out whether you need a local isolator. We also always suggest to people that they consider manufacturer's instructions as well. So that might give us the designer a guide as to whether we need to provide some local means of isolation. And also we remind people that there is a regulation which talks about, if your means of isolation is remote, that every isolator has to be either clearly identified by position or durably marked to indicate the installation or circuit it isolates. So if it isn't local, you would need to make sure that it's clearly definable what it is. So if someone was looking to isolate that appliance, where would they find the isolator? And also, if it is remote, there's also a requirement that it needs to be capable of being locked in the off position, so that if somebody was doing some maintenance on that appliance, somebody couldn't inadvertently re-energize it by switching the isolator back on, because they were distant and couldn't see the person performing maintenance. Would you add anything to that, Richard?
Yeah, nowadays, and particularly, I think here we were talking about appliances, but there's a wider spread with this, with new technologies and things like that, solar, and you might have something fed from more than one point. The isolation issue is pretty important, and the information informing people where these isolators are, because they're likely to be remote or in positions that might not be obvious, that needs to be clear. Sometimes this information is marked at the board, sometimes it's in OMs as well, and also the actual devices, the markings on the device, so that people can confirm it. In my job as an assessor, it is often the lack of labelling that you sort of pick up with them. It might seem small, but it's quite important. So
yeah, no, you raise a really valid point, especially about solar PV. So where we've got any additional source of supply, then that source is also going to need an isolator. And if they're dual sources or multiple sources into the same installation, then there's a requirement in 7671 for you to label the isolators to reflect that, so that, for example, if there was solar PV in an installation, people would know that not only would they need to isolate the DNO supply, but they would also need to isolate the solar PV supply, possibly the AC from the so in those instances we have to provide additional warning labels to make people aware of multiple sources of supply and multiple means of isolation in order to isolate fully. But yeah, it's a key point, real key point. I've got a request. Mistakenly, there was an engineer had put one question in the chat, and I had read it briefly, and it was about control systems and recording them on the schedule of results. But the system has lost that, so I just hopefully the engineer can cut and paste that and put that back in again, please. But if you do, I think I can remember the sort of the subject, so we will get to it for definite. But if you could retype that question in, that would be much appreciated. So yeah, apologies for that glitch, but that would be good. And while we're waiting for that to come back in, we'll take another one of the questions, and this is one that's quite an emotive subject, but it's very important. So when we look at this, because this is a question we get asked a lot, when testing a domestic installation, the coin operated meter has no funds and therefore there's no supply to the installation. Can I still complete an electrical installation condition report and record the live testing as a limitation? So we do get this from time to time. An inspector, and I mean inspector as in the periodic inspection and report, the person that's going to carry that out, turns up at a property only to find that it's fed from a coin operated meter and there are no funds, so there's no live supply and there's no possibility to do live tests. So what's our guidance there, Rich?
Well, it actually goes back to ADS, doesn't it, as well, about automatic disconnection of supply. You can't actually say an installation is safe if you don't know if it will disconnect within its disconnection times. No juice means you can't do things like ZE or ZS, or if there were no possibility there to sort of do that. So technically it is an incomplete report. The interesting thing about this, when you've done your dead test, you're doing it to a point to say that, well, the installation is safe up to that point, but it's really about its effectiveness when it is energized. We get this all the time in void properties and things like that, where the meter's been run up and it's been completely cut off. The dead tests are done, and actually at that point, really, the installation needs to be tested further to see that it's safe to remain on. So it would be strongly recommended that something is recorded on the report to inform the person. It's an incomplete report, really, so it's not a complete EICR until you can be sure, because the energization might show up issues when it is energized that need to be addressed, which could be potentially dangerous.
Yeah.
So therefore it's imperative to have it tested once it is energized. It's a difficult question, that one, to be quite honest, but it's something that a lot of people, a lot of my contractors would come across who do social housing and things like that, who are unable to, the installation is dead, there's no juice there at all. They can make an assumption on a design Z, but that doesn't mean that it will be safe when it's turned on. So technically it's an incomplete EICR. We get it a lot, where unfortunately the person that's been asked to do the periodic inspection doesn't realise this situation until they turn up at the property,
and then they can't get hold of generally the landlord that they're doing the test for. And the landlord wants the test done because he's got a new tenant waiting to arrive. So yeah, it gets very complicated contractually. So yeah, really difficult situation. And 7671 is a little bit silent when it comes to, it tells you what should be tested, but it does talk about the recording of agreed limitations and operational limitations. But that's really the situation, and we would as Richard has said, we'd strongly recommend that there's an insistence that when energy or supply to that property is restored, then the live tests are completed. We've got a lot of instances in a domestic installation where the operation of an RCD is required to provide compliance with 7671, and that won't be able to be tested without a supply. So yeah, it's one of those ones where we say that the person asked to do the periodic inspection has to be able to detail and confirm and report back to the person that what the implications of not having done any live testings are, and make it clear that the recommendation is that the live testing is completed before the summary of the condition of the installation is confirmed. So before we can give a satisfactory outcome, we need to do live testing. But yeah, difficult one. And so I think people learn from it. They only get caught by that once. From then on, they make it very clear to landlords that if there is no source of supply, they won't be able to complete the testing, but they'll still charge the agreed fee that they've done with the landlord, because yeah, unfortunately a lot of people get caught by it.
It's a huge liability. That, as you quite rightly pointed out, if the RCD, let's say for instance, doesn't work, and you can't check an RCD's function or simulate any issue with it unless there's energization of it. And if the RCD's used for fault as well as additional protection, you've got a number of issues here.
Yeah.
It has to do. That would be a key part of ADS, and you cannot confirm that disconnection times are met either via the RCD for fault protection if it's used for fault protection, or indeed that the RCD for additional protection is disconnecting in its time, or the MCBs until you've got juice.
Yeah. Okay, we'll take another question, and then we'll start taking some from the chat. So please, if you do have a question that you'd like us to attempt, please do put it in the chat for tonight, and we'll get to it. Just before we do that, again, one very common question that we get asked a lot: do I need to be concerned about the metal screws of a plastic light switch not being earthed? So typical domestic installation, we've got a plastic light switch with a plastic back box, and we've got screws there that aren't earthed, possibly because there's no earth in the lighting circuit, and we often get the questions, do I need to be concerned? And the answer to that is, that's a nice straightforward one. That the answer is no. Although you might consider that the screws to be an exposed conductive part in that they're conductive and they could be touched, and they're not normally live, but they might become live under fault conditions. So if there was a problem with the switch or the wiring within the switch, but there's a regulation within 7671 which makes it very clear, and it's regulation 410.3.9, and it says where we've got exposed conductive parts which, owing to their reduced dimensions, and it gives an approximate for being reduced as 50mm by 50mm, or their disposition, so that's location, can't be gripped or come into significant contact with part of the human body, and provided the connection with a protective conductor could only be with difficulty or would be unreliable, then they don't need to be earthed. They don't need to have a circuit protective conductor. and that regulation goes on to confirm in an informative note this exemption applies, for example, to bolts, rivets, nameplates, cable clips, screws and other fixings. So it's a risk-based decision. Although the screws could become live due to a fault within the light switch or the back box or the wiring or the enclosure, that they can't be gripped because of their size and their location, and so the perceived risk of harmful electric shock is low, and therefore they don't need to be earthed. Would you add anything to that, Rich?
It's very much about how you contact those things if they did become live. Interestingly enough, now, in particular with the plastic switches, you've also, if there is any risk, and I think sometimes you've got these situations where the initial wiring was in twin, and then someone's added on, and they're not using all class 2 equipment. That circuit itself should be labelled as to only class 2, and where a circuit is class 2 only, you could even put those screw cap coverings over. They come with a lot of switches now. Just insert those into the screw holes, and then there is no risk at all, is there?
Yeah. Okay, we'll take a look at the incoming questions. We've only got one in there at the moment, so you've got a great opportunity if you have got a question that you've always want answered to throw it into the chat, and we'll try and get to it. So the one that we've got in there at the moment, Rich, I'll read it. Thanks very much to the engineer for retyping it in. Apologies for losing the first one. So the question is, when carrying out inspection and testing on a new circuit, such as one supplying a heating system with multiple heating controls, how should this be documented on a schedule of test results? So typically the schedule records test results right up to the point of isolation, such as a switched fuse spur or isolator. However, should control circuits, including room thermostats and pumps, also be tested? If so, what is the best way to record these results, particularly when control wiring extends further and may result in higher fault loop impedance readings? So a really good question, and something that does come up not just in domestic, but very much so in industrial and control world as well, where we've got automated plants, and we've got control circuits out to valves and motors, temperature sensors. So all of those things then do come back, and they do fall within the voltage range of BS 7671, and so therefore do come under 7671. What I would say is that yes, they, because of that, they should be tested. However, that our standard forms that are in Appendix 6 are for general circuits, and if I'm honest, that doesn't fully align with DC control circuits, for example, where we've got a positive and a negative and no earth. We might have an overcurrent protective device, but it will be for the current carrying capacity, to protect the current carrying capacity of the cable, nothing to do with electric shock, for example. So yeah, it's one of those ones where you have to tailor the schedule of test results, and a lot of things might need to be removed. For example, details about R2 on a DC control circuit, because there won't be a circuit protective conductor. Alternatively, as I used to do when I worked in the world of automation and control, we would create our own test sheets for those control circuits, because yes, we would need to check continuity, we would need to check polarity, but there wouldn't be an earth fault loop because there wasn't an earth. So we would actually create one which we would agree with the customer, and we'd actually use them then for wiring and our commissioning results. So yeah, it is a great question, and it's often overlooked that people don't include those circuits. And the only reason where they shouldn't be included is if they were part of a a product. So if something came pre-wired, for example, and it was a standard product, and that wiring was part of the product, then that falls within that product spec and not 7671. But generally the control wiring should be included on our 7671 test results, but it's often omitted, in particular because it's not done by the electrician installing the supply. It's done by the heating engineer who's installed the heating system in that sense. But would you add anything to that, Rich?
Yeah, it's a very interesting, it's a very good question. Often, from an ERCR point of view, often it's something which people would write as part of the extent of works and say they're tested up to the fuse connection unit. Let's just say we're looking at a standard or a home central heating system. So they would only test up to that. But if they were being asked to check control wiring that was put in by other people, the advice I've given is to, on an additional page, list the tests that you've sort of done. So they're talking about things on stats or pumps and that, and back to wiring centers. They may well have done some continuity readings. They may well have done some insulation readings of the cables itself. And again, care's going to need to be taken of the things that are connected to it anyway. But they tend to, the advice I've given is to write that on an additional page, because the standard certificate doesn't have any information for it. On a new installation, brand new installation, there should be some form of specification sheet with the equipment that you can compare that with, and that may well also require to be attached as an additional page or notes page in this certificate. But there's no real way of documenting it. You could put information relating to the testing of those and the commission of those parts on an additional page, along with any manufacturer's documentation to show that you've met their sort of requirements, and that you've met their specification.
But it is a great question, and it's something we do get asked a lot, and ultimately those circuits voltage wise fall within the scope of 7671, so they should be tested in accordance with 7671, although we do wholly accept that the standard generic test sheets don't really cater for them. So as both myself and Rich said, either alter the standard sheets, making it clear, or actually create one which is more relevant for that type of circuit. We've got another one that's come in from an engineer, and this is quite a topical subject too. So what's the correct procedure for tails to EV boards? Are 10mm tails from a Henley Bock fed from a 100 amp supply fuse acceptable? So we were, I'm just trying to get my timing right now, I think it's a couple of years now. A couple of years ago we got involved with the EV audits that were done on a lot of the electric vehicle jobs, which took use of the grant for domestic installations at the time that was provided by OLEV, or OZEV as they are now. OZEV. And what we were finding was that people were splitting the tails and going from 6mm conductors to the EV charging equipment, and when asked about it, they were quite rightly saying that the overcurrent protection of those 6mm tails was adequate, because the charging equipment wouldn't pull any more than 32 amp. It had an overcurrent protective device limiting the current in those tails. And that's acceptable, because 7671 says you can do that if you can ensure that those tails will never be overloaded. However, what we did uncover was there's also an issue of, because you've not only got to consider overcurrent protection, you've got to consider fault protection, and by fault protection that would include short circuit. Now again, you can omit that if the DNO fuse provides protection and the DNO allow you to use their fuse for that. Now they will only do that if you've got adequately sized tails. So yeah, that's where what it comes down to. You've got to ensure that you're complying with 7671 requirements, not only for overcurrent protection but also for fault protection, and in particular short circuit. So yeah, we were seeing some installations where they had single insulated conductors, not very well installed, and there was no means of protection against short circuit. So that's what you've got to think about. If you are downsizing the tails because the current carrying capacity is okay, how are you protecting those smaller tails against faults? And in order for you to use the DNO supply fuse to do it, you've got to get their permission, and we all know that that's not readily available. So how are you complying with both overcurrent protection and fault protection that's required by 7671? Have you come across that issue?
Come across it fairly regularly, and often the I say fairly regularly. It's something you see often, and very often that the answer is, well, it's only a short run. I'm saying, but it's this side of the board, so it's on the supply side. Have you spoken to the DNO? I think the key thing is that you should consult the DNO, and the DNO will advise you on the size of tails there.
Yeah.
And you go by that. It is their equipment. Effectively, you are coming off of a meter into Henleys, which, let's say, for instance, there were 25 or 16 mil. 16 mil would often issue that there's a 60 amp in the head, but not always. You need to get their permission and go by what they say there, not just take it upon yourself and just put in what you think, because the thing is, you've only got 6 mil coming out, and that's on a 32. It's the supply side that you're not considering there, and that does need some sort of consultation.
Yeah, and consideration needs to be given to how those smaller tails are installed. How are they mechanically protected? How are they installed? So is it durable? They're not under stress. We did see some quite horrendous things during that audit. Okay, we still got availability if people do want to put some more questions in the chat. While we give that final opportunity, we'll just look at one more question that we had from previous. So this was again quite an interesting one. If the volt drop in an installation is greater than the 5% stated in 7671, can I use equipment if the manufacturer confirms that it will operate safely at the lower voltage? So we were talking to someone who had quite a lengthy, quite a long circuit to some, it was just lights. Was concerned about volt drop. Wasn't really an option to re-cable it to reduce the volt drop, and was just asking the question: can they run equipment if the manufacturer confirms that it will operate safely at the lower voltage? So what's our thoughts there, Rich?
If the manufacturer confirms that it can run at the voltage, and it would be permitted. The manufacturer's given the instruction there, and would go by that. There are some. It's not just lighting. It could be motors or things have a start-up current and drop the voltage as well. They're designed that way. It's a short period, but yeah, if the manufacturer gives that information, and really only if the manufacturer gives that information, would you then say it's okay. In all other cases, in the absence of any other consideration, you really do need to meet the 5% for equipment and the 3% for lighting.
Yeah, and it's true that there are some references, and 7671 does say that in the absence of other considerations, under normal circumstances, the voltage at the terminal of any fixed current use equipment shall be greater than the lower limit corresponding to the product standard relevant to the equipment. So again, as Rich said, if the manufacturer's instructions or the product standard for that says that it can tolerate a lower voltage, then again that's not an issue. And mentioning motors, also there's a specific regulation 525.204 that says you can have a greater volt drop associated with the motor for starting periods, because that takes into account the effective inrush current. So it is possible. I think the 3 and 5% are sort of a generic standard. Okay, well, we don't have any more questions in the chat. We're just about to roll over in time as well, so we'll just tell you about a few things that are coming up. First of all, if you haven't already downloaded the Pocket Guide app, please do. It really is a useful tool. It does have all the original Pocket Guide information. It's got a number of calculators in there as well, and links to best practice guides. Really useful tool. So if you haven't downloaded that already, please do. Our wire webinar series is strongly on the go, so we've got 2 more that are coming up before we take a break at Easter. So we've got a wire webinar on EICR coding clinic, which is coming up on the 13th of March, and then in April we've got a back to basics or fundamentals about the subject that we talked about earlier this evening, automatic disconnection of supply. So yeah, please do, if you haven't already, please go onto the website and register for those upcoming wires. We've got a few more. We'll just try and sneak them in. So can you use LIM on a minor work certificate for an additional alteration to a circuit as part of the existing circuit can't be fully inspected as contained within the building fabric and inaccessible? LIM not something I would normally use for initial verification. Okay, I think if I'm reading that correctly, you're saying that you're able to adequately test and inspect your additional alteration, but you can't test and inspect the full circuit. The circuit can't be fully inspected as contained within the building fabric. Well, that's acceptable. So you make it clear that you're only responsible for inspecting and testing your additions and alterations, and that the existing circuit was already there, unless obviously as part of your testing it throws up some information that concerns you. So for example, insulation resistance is very low or continuity very high, and therefore you might be thinking about damage to the cable. But generally you wouldn't be expected to inspect the existing installation, only what you've done. So yeah, you don't need to record it as a limit, because it's not actually part of your work which is covered by the minor work certificate. The minor work certificate is for your new addition and alteration, not for what was there already. You have always got the ability to comment on the existing installation, so perhaps make a comment that you were unable to do something which you wish to do, but so long as you've got no concerns and it doesn't appear to be affecting the safety of your additions and alterations, that would be fine. Would you agree with that, Rich?
Yeah, I do. I think, and I don't want things to sort of get mixed up here. If you're going to connect onto a circuit, you would need to to know that that circuit has the capacity. That's what your comments on existing is all about. And in actual fact, that the installation has the capacity for that anyway. When we say the installation, you know, is it an earthed installation? The circuit itself has got sufficient, or the existing circuit has got sufficient capacity for that additional point. You're not expected to see things in the skin or which are concealed, but you would know that by measuring at that point that there was earth in there, that ZS would show that up. And by adding to it, are you going to exceed the ZS max of that circuit by adding to it? Again, it needs to disconnect. Has that circuit, if the circuit needs an RCD, has it got an RCD? Is the RCD of a right type? These are the sort of things you're looking at, and whether your part of the circuit now needs to be brought up to, or does it need an RCD on that point? It's you are doing some sort of survey, and that information should go into your comments on existing.
Yeah, and I think the engineers specifically mentioned that it can't be fully inspected. So
yeah,
that would be, you know, you wouldn't be expected if in particular for the example that was given where cables are buried in the wall,
yeah.
You know, you would not be able to. We've just got one last one which I think we can cover off fairly quickly because it's a best practice guide 4. So should the lack of an SPD be recorded as a C3 or an observation or no code at all? So if we look at best practice guide 4, which is produced by Electrical Safety First, although there's a whole group of industry stakeholders, including ourselves, including City and Guilds, ECA, the IET, NAPIT, Select. So everybody contributes towards Best Practice Guide 4, which is where we give that generic guidance for condition reporting. And lack of SPD, lack of SPD is one of the things which is highlighted there. So I'm just going to pull up the right reference. So absence of surge protection devices where required by regulation 443.4 1 and 3 is recommended as a C pardon me, C3. Recommended as a C3. To that engineer, I would strongly suggest downloading a copy of Best Practice Guide 4 from the Electrical Safety First website, and there you'll find the industry agreed recommended classification codes for a whole range of issues, and right at the top of page 21 of that free downloadable guide is the fact that we would recommend that as a C3. Thanks very much for contributing. I hope that you found it useful and great opportunity to get questions answered. Please do stay in touch, keep up to date with all the latest news and industry across the NIC social channels. Thank you very much for participating. We have got another opportunity just because of the way that the wire schedule has happened. We are going to be doing another Q&A next Thursday because we're into March next Thursday. So on March Thursday the 6th, we will be doing another live Q&A on Thursday night at 8 o'clock. So if you didn't get an opportunity to put your questions in tonight, then please do next week. And thank you very much for those that did. Any closing thoughts or comments, Rich?
No, it's been enjoyable, and the new the coding Q&As or the coding clinics seem to be the ones that contractors are going for a lot. The SPD we talked about tonight. AFDD is another one, which is a C3 where it's required. These are new and type AC RCDs where DC coding gets added all the time. So my advice: use Best Practice Guide 4. Use your pocket. This is all available in your pocket guide, as you alluded to earlier.
Yeah.
So much information and additional things going on there all the time. It's a brilliant tool.
Yeah, really good. I'd strongly advise, having a copy with you, and then when people do question you and query you about why have you coded something, you can provide them with that evidence that it's not just your recommendation, it's an industry agreed recommendation. So yeah, really strong to have that as a backup. Okay, well, without any further ado, it's always the quickest 45 minutes. I do appreciate we've run over tonight, but yeah, it always is the quickest 45 minutes of the month for me. So thank you very much for those that contributed tonight. Thanks very much, Rich, for joining us, and hopefully we'll see you again perhaps next week. Thank you very much.
Thank you.